Good
Hello,
morning,
Bob.
Andrea.
Good morning, Bob.
Or good afternoon, I should say. Good evening.
Yes, okay. Good evening also to all our people attendees that maybe are in this part of the world. I'm based in Europe and Bob is based in the US. So it's 8 hour difference more, 7 hours now, probably.
Yeah, I don't even know. Well, what's it now? It's 11 o'clock in the morning here. So
Okay, it's 5 here.
okay,
Five,
so 6 hours. There we
six
go.
hours only, yeah, yeah. Okay, thank you to our attendees and this new GMI webinar. It's dedicated to EX inspection. We have our, let's say, top guy in for this aspect, which is Bob Johnson. And we have this new webinar. We want to just highlight one point, very important, that we go through the presentation. So please use your Q&A button if you want to make questions, because we try to answer. Bob will try to answer during the presentation. And this webinar will be recorded and you can have a look later and maybe forward to the all relevant people you may know. So today's speaker, of course, we have Bob Johnson. So he's a very experienced guy, more than 30 years experience in this market. He's, of course, is president of Source IX company in the US. Is also activity in instructor accessor for ICX schemes. Also perform a lot of inspection all over the world. And I think you will get some good information today.
Hopefully.
Myself, yeah. Myself, Andreas Poror, I'm a global account manager, international, GEM International. I'm also project pursuit leader, and I'm working in this market in GMI since 2015, and I have more than 20 experience in automation and process applications. So next, just a few words. So GMI is say giving for free this webinar to our attendees. Please, if you want to get the certificate, let's say from GMA, you have to stay at least 75% of the time. We will rest for all 100%. So please let me just quickly introduce the company. So what is GMI? For the people that don't know, GMI produce intrinsically safe and sealed devices for main packages, DCS, SD, fire and gas. We work in a critical sector like oil and gas, petrochemical, pharmaceutical, fertilizer, mining, and food. More than 40 experience, founded in 1993, but our experience started in Icon Instruments. We produce in our factory in Milan, but we have also presence in all 5 continents. Next, Bob.
Sorry.
Oh, yeah, no problem. Yeah, this is the product package. We produce intrinsically safe barriers, so isolators, seal safety relays, isolator for non-AS applications, safety power supplies, multiplexer for temperature and digital signals, termination board for main and almost all PLC and DCS in the market. We have hard multiplexing, surge protection, and also last bullet is regarding our course and services we provide, because beside the webinar, we have also organized functional safety EX courses. Next, so few more information. We have a complete state-of-the-art technology, complete traceability for incoming components and outgoing products, 100% testing on all products, and fully automatized production. And we provide a 5 years warranty and 10 years guarantee availability for all products we have in our product portfolio. Next. So regarding certification, products are certified by more than 15 independent agencies. So we have a certification for Europe, for America, for a country like India, China, Japan, for Middle East, for Brazil, of course, for US, like UL and FM. We have a different certification that cover, say, the application requirement. All products, of course, are, yeah.
Yeah, no, I was going to say it's funny. I was
Yeah.
having a conversation last week on an inspection, and we were looking at GMI barriers, and they were like, "Holy cow, what do I look at? There's so much stuff on here." So, yeah, you have almost every cert that I can imagine. It's all on the side of a of an isolator, and you got to pick out the right stuff to make sure that hey, this is suitable and what's really what's the important thing that we need to look at. So.
Okay, good, good, good. Yeah, and customers, we provide solution for all system vendors, for the EPC and the OEMs and the user. Basically, we serve mostly system vendors and OEMs, and of course, system integrators company. Okay, next, I think I leave now Bob for the very interesting point, which is in X inspection. Please go ahead, Bob.
All right. Well, thank you, Andrea, and thank you all very much for participating today. We had a lot of really good questions posed that you guys sent in, so we'll make sure we have some time to basically try to answer those kind of the key questions. And I know we may or may not be able to get through everything, so certainly at the end of the presentation, if you have additional questions that come up, feel free to either ask during the webinar. You can type it in, and we'll be checking that out. And then certainly, but even if we don't get to your specific question, I had a question this morning came in from a gentleman from Canada, and I won't be able to answer it here, but I'll answer them offline. But we certainly want to try to answer any questions that you might have either today or tomorrow or sometime down the road. Please feel free to reach out to us. So EX inspections, why it's important. I understand that most of you are probably not necessarily inspectors. You're probably involved in either the manufacturing or design of intrinsically safe systems. But of course, one of the things that's really important and what we always tell people is that, look, you can spend all this money, you can spend all this design time on very highly expensive specialized type equipment. But if we put these in the hands of individuals that don't truly understand what they're doing as far as the installations or the maintenance, then we very well, in many cases, can just override a lot of the, again, very expensive equipment that we're installing and using. So again, we use the analogy, the chain is only as strongest as the weakest link. So we have to have strength at the manufacturing level. We have to have it at the installation level, on the maintenance level. And the whole purpose of our EX inspections are basically just going in and making sure that, yes, this system, if you will, that's being built is designed in accordance to the relevant standards. The one thing that I always tell people, and I actually had a customer this morning reach out about us doing an FAT form, a factory acceptance test. And an EX inspection is different from an FAT because a functional test is basically making sure that obviously everything works well. It's all designed to work if it's PLCs with the logic and all that good stuff. From an EX perspective, I honestly don't care if it works or not. What I care about is the mindset is there anything here that's installed that potentially could be an ignition hazard? So that's really what I'm looking for and what EX inspectors are trying to really determine, if you will. So whether or not an EX inspector cares about the fact that we turn a switch and it turns on or off, that's not really the main focus. It's again to try to make sure that there is no potential ignition hazard by this equipment and how it was installed or maintained. So what standard do we follow? And more or less, the good thing is here is that the base standard that almost everybody else in the world follows is the IEC 60079-17 standard. Within Europe, we call it the EN version or Euronorm version. We've also published that here in the United States as a UL version. In Australia, we have it as an ASNZS. Brazil, we have an ABNT NBR standard. They're all pretty much the same. And then what happens is that typically clients will take those boilerplate templates, if you will, that I'll show you here in just a little bit, and they'll take that and they'll modify it for their particular project. So they'll take the base inspection tables, if you will, that are published out of the -17 standards, and then they may modify them slightly for a project-specific requirement. So the good thing is once you understand the base standard, you pretty much understand all of the standards around the world, because we're all pretty much singing from the same hymn book, as we like to say. So the Dash 17 standard is key. So again, we will take that information that's in the 17 standard, and then again, it's important to understand that companies will take it and then they'll modify it for their own specific use. So every time that I'll do an inspection project for a customer, I have to ask them, is there something outside of the scope of the Dash 17 standard that I need to make sure that we follow? Maybe it's a particular brand of product that they insist upon, maybe a cable gland brand, or maybe there's something above and beyond that's actually out of the Dash 17 standard. So it's always important as an inspector to understand, what are we inspecting it to? There's also standard wiring regulations that we have to comply with as well. Now, these are not necessarily referenced within the Dash 17 standard, but the UK has wiring regs, Australia has wiring regs, the US, Canada, we all have different wiring regs. So we also need to make sure that we incorporate any of the standard general purpose wiring regulations when we're doing these EX inspections. So what do we need to know before we do an inspection? What is it that we're expected to have? And this is important for people that are building skid packages, or you may be having an EX inspector coming into your facility and is going to inspect equipment. What is it, the things that I want to see before I even undertake this inspection? So again, what is the regulations? What's the client specifications? Information on what grade of inspection to be done. Now, as we'll talk about a little bit later here, we can do either a visual, close, or detailed. Generally, that initial inspection is called an initial detailed inspection. This is where we open up everything. Everything is de-energized. We're looking both exterior and interior to that piece of equipment to try to find any issues. We also need things like a bill of material, drawings. Certificates are very important, because certificates will have, in many cases, what is called an X condition. And an X condition is a special condition for safe use. We want to make sure that that equipment is installed in accordance to whatever it is on that certificate. If it has it, we need to make sure that it's installed in accordance to that certificate. Obviously, a register, a database, and then data sheets on all the equipment. One of the things that we ask for, and sometimes it's difficult to get, is what is the area classification? What zone? What category? EPL. Previous schedule inspection records, if it was already done. If this is an ongoing thing, we want to see the prior inspection records. What gas groups? Ambient temperature range. This is one thing that people forget to make sure that we supply that to our inspectors. We're doing a project in the Middle East. The ambient temperature range may be +50 or +55. If we don't know that information, we can't tell if a piece of equipment is suitable unless we truly understand the ambient range. Certainly temperature codes, we need to understand that. Is there any specific environmental issues that we have to be concerned with? Minimum IP ratings, maybe material requirements. And again, there's that X condition. And again, without the information, somebody calls me up and says to do an inspection. If I don't have that information, I will stand there and look kind of like I don't know what I can look at. I really need to have this information, right? So these standards, again, is the Dash 17 standard. And as I mentioned, there are 3 grades of inspection. So when we do teaching and we do training students to become inspectors, they have to actually go through this process. So a visual inspection, this is where we just walk up to a piece of equipment and no tools are necessary. This is, you don't have to be necessarily a EX trained person to be able to do something like this, because all we're looking for is things like maybe a bolt is missing, maybe there's a hole drilled in a light fixture, or maybe there's water in a light fixture. Those types of things, they're fairly obvious. When we move into a close inspection, the definition is now that we're using tools. So we might use a stepladder, a flashlight. We're now starting to look at labels. We're checking to see if the cable glands are nice and tight. We can do both of these inspections without de-energizing the equipment. And here's the important thing. We do not open a loose gland under a close inspection. We only check it to see if it's tight and appropriate. If we actually find a loose gland, we might want to look inside to see if maybe the armor is clamped properly. We would only do that under a detailed inspection because we must de-energize that piece of equipment before we do that. Then when we get into our detailed, we go with our lockout tagout procedure. And this is where we're starting to look at things like internal faults. Maybe gaskets are missing, damage to flame paths, maybe damage to any other internal components. Those are what we do under a detailed inspection. Now, there's also what are called types of inspections. And also we have to take into account, again, as I mentioned, what are the specific wiring regs, the general purpose wiring regs. So we need to understand that as well. So our inspection types, we have types of inspections. So we have 4 different ones. The initial inspection, that's when we do it at the very beginning. That's our initial inspection before the equipment is put into service. Now, a periodic inspection will be carried out on a routine basis. A sample inspection is that we're going to inspect a proportion of the equipment. Now, the sample size can be determined by typically the client or whoever the regulator is involved. So instead of opening up every single cable gland for an installation, we may say, hey, we're going to open up 5% of the cable glands. We're going to look at if we can get a good feeling that the 5% are good, then we can make an informed decision that, okay, we're okay. On the other hand, if we open up a sample size and we find that there are some issues, we might increase that sample size, or maybe we may have to go through a full detailed inspection on every one of them. Hopefully not, because some of these projects have literally hundreds, if not thousands, of cable glands, and we don't really have the time and energy to be able to do every single gland. But typically gland inspections, after it's gone through its initial detailed inspection, once it's in service, we do a sample inspection. And a continuous inspection is where it's done on a routine basis. So if we're actually going out to maybe check on motor bearings or windings or something like that, while we're out there doing that, we might as well do an inspection from an EX perspective. Is there any damage? Is there any corrosion? This is kind of an ongoing process while we're doing other routine operations or anything like that. So within the standard, there are different inspection charts for the different types of grades of inspection. And there are inspection tables, if you will, for D, E, and N equipment. That's all in one table or one chart. There's a separate inspection schedule for EXI, for intrinsic safety. There's an inspection schedule for EXP. And here recently, the -17 standard has been updated to include now an inspection schedule for EXO, which was liquid immersion. So other protection concepts that you may be familiar with, such as maybe some of the optical radiation, or maybe S, or even T, for example, for dust. These inspection charts will use these similar charts for those pieces of equipment. So they don't have necessarily a specific chart for EXM encapsulated equipment. And part of the reason for that is that M equipment will be typically on a component level, and it'll be part of something that might be part of an EXD panel or an EXP panel. Now, these are examples right out of the inspection tables. These are the tables. So what you see over on the right-hand side, you'll see a D, C, and V. That's our grade of inspection. You'll see the protection type, EXD, EXE, and EXN up at the top corner. And anywhere you see a little check mark, that's where we will do an inspection and we'll look at this information. So for example, A1 is the equipment appropriate to the EPL zone requirements of this location. Well, we can do this typically as a detailed inspection. We do it as a close. Visual might be a little bit difficult because, again, we're maybe not standing right next to it, but we're going to look at the label. And again, as you go across, that will give you information as to what you should be looking at if we're carrying out, say, for example, a detailed inspection. And there's about 50 to 60 lines on the inspection check sheets. Some of them are product specific, maybe for heating equipment or for lighting equipment or for motors. And then some of them will apply to all equipment. In the A section, that applies to all equipment. When we get into the installations, that's in section B. This is where we're taking a look at things like the cable. Is there damage to the cable? Have we used the appropriate cable glands? Are we using certified stopping plugs and all that other good stuff? This is where we get into those types of issues. And then finally in C, this is our environmental. Is there a buildup of dust or dirt or grime on the equipment? Is it hot to touch? You know, is there something there from an environmental standpoint? Are we seeing significant amounts of damage due to corrosion? This is where we're doing all of those. So these are our inspection check sheets. And again, from a designer standpoint or from a manufacturer standpoint, it's good to understand this, because if you're going to have an inspector come into your facility and check this material out, well, if you do a check ahead of time, you know, again, not so much as a manufacturer because you're producing a IS barrier or a cable gland, but if you're a package systems manufacturer or an integrator where you're taking a lot of equipment from different manufacturers, putting them all together, it's really vitally important that you understand this and you do a lot of this ahead of time. So by the time the inspector actually comes in, everything is A-OK. There's no last minute, oh my goodness, we've got to change everything out and we have all kinds of problems. So a couple things as far as conducting an inspection, right? What are some of the key things, right? The knowledge, skill, competence of an inspector. Does this inspector understand exactly what he's supposed to be doing? And is the inspector qualified? I can share with you in many cases, you know, again, I do inspections. I don't claim to know everything. And I don't like inspectors that basically just like say, well, this is the way it must be, no ifs, ands, or buts. Because I have seen work from other inspectors, and I've had people call me say, hey, the inspector told me I needed to do this. And I'm like, nope, that's not what the standard says. So I'm not saying that you should always question an inspector, but I would say that, you know, understand that not all inspectors are perfect, and inspectors should act as if they're not perfect. They should be humble. They should be open for conversations. But I don't particularly care for inspectors who just want to rule with an iron fist and you can't talk to. Again, the scope of inspection, what are we going to be looking for? What is our type and grade? What's our documentation? Availability of facility personnel to assist. This is important because as an inspector, when we're going in to look at equipment, we really don't want to be opening up the equipment ourselves, because now we're putting ourselves, if something gets damaged, then we are liable. So we typically want to have a plant person work with us to actually open and close pieces of equipment. Can we de-energize? In many cases, we can't. So this is sometimes a problem because we, especially if it's an ongoing thing, we don't have the ability to de-energize. So we have to make an informed decisions. Access to the equipment. How can we get there? Sometimes it's we may need rope access, or we may have to be on scaffolding or ladders. And then what is the type of equipment and what environmental conditions? Here's the important thing to note as an inspector, right? Safety is the utmost priority. We don't want to compromise safety by doing anything like taking equipment into a hazardous area that's not either certified for a hazardous area, things like even cameras, key fobs, computers, unless they're certified or we have a gas-free permit. Opening energized equipment without a gas-free permit, operating any of the controls without facility personnel. And this is the important thing, not recording anything you believe may be incorrect or unsafe. I always tell new inspectors that if you think it's an issue, go ahead and write it down, because you will have an opportunity to go and review later on when you look at the standard, you look at the specifications, maybe we look at some pictures that we have taken, and we actually determine that, hey, it's okay. But it's always better to record it. If you think it's unsafe, go ahead and record it. So Andrea, we have our first poll question.
Yes. Okay.
So we have a poll question, and go ahead and answer it. You won't be graded, don't worry. While you guys are doing that, we did have a couple questions. It says inspectors adhere to the design documentation given in like hazardous area classification drawings. Is it possible for an inspector to raise concern if the firm's drawings are ambiguous? Does this fall under their scope? That's a great question. Yeah, it's always appropriate, I think, personally, is if there's a concern about maybe the drawings of the area classification, and I've been involved in this, where I thought that the area classification should be changed based upon my experience. And actually, based upon that, we had conversations with the regulators, the client did as well, and we provided them some documentation, and they actually did revise their area classification drawings. Now, again, that's not necessarily our role, but it is a valid point, and it does come up. And I would always say, if you have experience in this type of equipment and where it's being installed and you see an issue, absolutely bring it up, no doubt. And then the second question we had was, do we have any suggestions, Al, the best way to inspect flame paths on EXD equipment? How deep a scratch do you consider a fail? Oh boy, that's a difficult one. We'll talk about that. I'll say that a little bit later, but it is a good point. And I'll show a picture here a little bit, and I'll ask you guys if you think it's a fail or not. So as far as which of these are not a grade inspection, I think a majority of you did say it is that initial. That's a type of inspection. Visual, close, and detailed are grades of inspection. So initial is a type of inspection. So good job. All right, let's continue on. So I'm going to show you some real world examples of some common faults. Obviously, we can't have you raise your hands, or I'm not going to ask you to do all that good stuff, but this is fairly obvious. This is on a land rig where the people did not understand the purpose of a flame-proof enclosure and left all the bolts out to make it very easy to get in and out of it. So that is obviously something that we would typically find under a visual inspection. We could see this from a mile away. So bolts missing would be definitely an issue. Nameplate information is a little bit difficult, but I think if we cleaned it up, we could probably figure that out. The fault here is where we're using Teflon tape in cable glands going into flame-proof enclosures. So Teflon tape is a big no-no, and it's very commonly done. People use them because they think it provides an extra watertight integrity. What we do say, and what the standard does say, is that we do want on any flame paths to use a non-hardening grease. So some sort of thread lubricant to provide an additional layer of ingress protection. But the good thing about a grease is that if we have an explosion on the inside of this housing, the flame path will still operate as it should. The Teflon tape blocks the flame path, which could lead to pressure piling and a catastrophic failure of the enclosure during an explosion. You'll also notice the use of a shroud in this case. Shrouds are fairly common, although not nearly as common as they used to be. I always recommend to people don't use shrouds. Use a high quality gland, because the problem is with a shroud, it covers up a lot of the issues. And if we're inspecting it, I need to take a look at the gland. Well, guess what? I've got to remove that shroud to be able to see the markings on the gland, and also to check to make sure that, you know, the gland is tight and all this good stuff. So generally speaking, I would highly suggest not using shrouds, but I do know it's on many specifications, and they're still widely used, but I would highly recommend not using them. This is a fairly common one as well, where somebody buys a piece of equipment and they'll have what they call traveling plugs or temporary plugs. So this little red plug on the side of this transmitter is there during the shipping process, and it never got removed and replaced by a certified EXD plug. So obviously, if we had arcing or sparking going on inside of that flame-proof box, that plug would just fly out, and we would have a catastrophic failure. So again, this would be something. This would be something that we would definitely want to highlight, and we could find under a visual inspection. Yeah, and another question that came in with the emphasis on the cons of using shrouds on cable glands. getting back to that, I'll show a picture here a little bit later that'll show you something that hopefully will answer that question. Now, taking a look at this one's a little bit, just by looking at it, we see this as most likely a flame-proof enclosure, which is designed to contain an explosion. However, we see that we have nylon cable glands going into those. Now, nylon cable glands are rated, some of them are usually EXE, and they're designed for use on EXE enclosures or lights where we do not have an internal explosion potentially taking place. So if we had an explosion on the inside of this transmitter, those glands would certainly not do us any good. However, this may be installed according to the intrinsic safety requirements because transmitters will have multiple ways of doing an installation. So we need to check further to see, hey, was this installed as intrinsically safe? If that's the case, a blue gland or a plastic gland would be suitable, but we would certainly need to indicate the cable in some way, shape, or form, blue as one example, that this is truly an intrinsically safe installation. And I can vouch that this is not an intrinsically safe installation, so those glands and cable would have to be removed and replaced. This is another issue where you see a label, and I have another picture of this a little bit later on, but if you kind of look over from the left-hand side to the middle, to the middle, to the right, you'll see 4 different marking strings. There's one for EXD, there's one for EXIA, there's one for EXIA for dust, and then there's finally the EXNA on the far right. Well, typically you'll see little check boxes, and that'll tell us as an inspector, hey, how is this being installed? And in this case, we don't know. We really have no idea. Was this installed as intrinsic safety? Was it installed as EXNA, non-arcing, or was this done as flame-proof? So we need to know that information, and many of these labels from manufacturers will have multiple certificates for multiple different ways that we can use this product. So generally what we tell people is like, look, you get this transmitter, you get this piece of equipment, go ahead and put a check in one of those little boxes to tell us, hey, how is this supposed to be installed? How are we doing this? And when we put on the register, if we're doing it as EXD, we're going to include the certificate number. The certificate number will be the one on the far left. That's the certificate we need access to, not the other 3 certificates, because they mean nothing to me at that point. Now, what the issue is here is that this is obviously an improperly poured or cracked barrier gland. And of course, we would find this only as a detailed inspection because we are not supposed to be opening up glands unless this has been completely de-energized or we have a gas-free permit that allows us to do that. So opening up a gland like this is what the things we want to look for to see if the compound is cured, if it's surrounding all the individual cores. In this particular one, it looks like there was actually a shroud wrapped around the cables, which actually would have to be removed as well. So this is not a good thing. What's our issue here? Well, again, GMI makes a really great product, but you notice that we see some stranding, if you will, coming out of those conductors. We don't want to see any stranding. We want to typically have bootlace ferrules. We also have a shield that's just floating there. There's nothing being done with that. So there's a couple different issues here that we have with our IS installation. So we just can't install it, just, strip back the cable and just stick the conductors in there, tighten it down and say, hey, we're good to go. We violate a couple different things as far as minimum distance requirements between the terminals or between the conductors. And again, too much copper showing. We're not dealing with the shield in the appropriate manner. We also have some just cut conductors that are just sitting out there. So there's a bunch of faults with this one. And again, this would be typically under a detailed inspection. This one's a little bit difficult. It is probably something that we would find under a close inspection because we're going to go look at the nameplates. Well, unfortunately, this nameplate is such to where it's very difficult to read, and we can't find a lot of the information that we're really hoping for. So that's a big issue, especially with labels on equipment. There was a question that came in also, blue cables and cable glands, UV resistance. I will tell you the blue cable glands typically are made out of the same nylon that they use for the black ones. So they do carry typically the same UV rating. And a lot of the blue cables that you will find will also have the same UV rating as well. I don't want to say that generally, but most of the time they will have the same ratings as if it was the normal cables. And that does bring up an interesting question that always gets asked, is intrinsically safe cables, do they always have to be light blue? Well, that's not what the standard says. The standard actually says if we are to use a color coding for intrinsic safety, it shall be light blue. That's different than saying you must use light blue cable. What the standard actually says is what I just told you there, but it does tell you you have to indicate that that cable is intrinsically safe. So could we use, say, a small piece of blue heat shrink where a cable gland is located going into a box? Yes, you can. Could we put a tag on that cable saying this contains intrinsically safe circuits? Yes, you can. Now that's what the standard says, but many clients will insist upon light blue cable, and you can't argue with that. That's their specification, so therefore we must comply with that specification. But the standard does not say that, and there is a lot of confusion in the world with regards to the use of light blue cables, that we must use light blue cables as per the standard, and that's not the case. Oh, let's see, there we go. So again, we have water accumulating on the inside of a light fixture, which is causing rust and maybe a shorting out of this particular light. That's again a detailed inspection. However, if you notice, there's actually a water line on the inside of that light fitting. And if we saw a lot of standing water on the inside of this light and it wasn't working, we probably would have found that as a visual inspection or even a close inspection. And then if we saw issues like that, we'd say, hey, de-energize, let's go ahead and open this up and find out what's going on. So kind of going back, another poll question, what standards do we follow for EX inspections? And you guys are just nailing it. Everybody was paying attention. Fantastic. So I know we got a lot of material to cover, so we'll continue on. But yes, -17 is the right standard. Just as referenced, the -14 is our installation design standard. The -1 is the standard for flame-proof equipment. The 10-1 is area classification for gases and dust. And by the way, we had another question with regards to that nameplate where those little check boxes were actually there, and whether or not that should be done by the installing contractor or whom. And yes, to answer your question, it should be done by whoever did the initial installation. They should go ahead and put a little mark on that checkbox to make sure that it is done. Now here's a flame path. This kind of goes back to the flame path issue. Now, obviously, this will be found under a detailed inspection. Now, this particular issue is typically if we had a gouge like that, and it was running probably at least a halfway across the flange, in my opinion, and even though that's maybe only a millimeter deep, I would say that's a problem. But in this case, we actually have a gouge that's running perpendicular to the flame path. In reality, this is a judgment call. What we do require in the standard for doing an inspection on flame paths is use a feeler gauge. And we take a feeler gauge, and the feeler gauge is not going to catch something like that. That's actually some damage to the gouge. So this is a little bit of a judgment call, and it's up to each inspector to kind of make their determination of how we feel about that particular one. There isn't, unfortunately, tremendous guidance within the -17 standard to determine, hey, how damaged is damaged, if you will. This is left up more towards the client or the regulator to make that determination. I would, in this case, as an inspector, take a picture of this. I would share this with the client, and then I would say, you make that determination. I'm not going to make that determination, but if you take my opinion, I would say that's okay. But again, I'm not going to be the one who's responsible for that. So another question, dust classification 10-2, yes. And 10-1 is for gas. It's just for gas. And I apologize if I said 10-1 was for gases and dust. It is 10-1 for gases and vapors. 10-2 is for dust. So if I misled you, I apologize. Our fault here is obviously water filling up on the inside of these flame-proof boxes, right? Again, it's done as a detailed inspection. We would probably see, hey, we're having a problem with this motor. Why is it not working? So therefore, we'd find in this scenario. Here again, this could be done at this point really under a close inspection, although we're really not supposed to disassemble the glands. But in this case, we found that the armor was not clamped to the clamping mechanism on the inside of the gland. So we would need to have these re-terminated. If you notice in the background, we have a bunch of shrouds, right? And so somebody who has a bunch of shrouds, we're going to have to remove those shrouds to actually go and inspect this gland. So that's another reason why I don't like shrouds, because I've got to remove them and then you're going to have to replace them. And that's not fun to have to replace a shroud. You have to re-terminate the cable, slide a shroud up and over it. So again, another reason why you just don't want to use shrouds. So what we have here is actually a couple different issues, but we have in this case probably an issue where they didn't use barrier glands and then were realizing that they needed to use barrier glands. They may have filled them up with some compound and then used some putty on top of that, and away we went. So part of the issue of barrier glands is that we actually have to seal around the individual core conductors. The ones that you see in the front on the left, that blue cable, and the one in the back, that black cable, if those are single core cables, well, okay, we didn't do it right, but at least we potentially sealed around the individual core. But I'd venture to say if we took those apart, those are multi-conductor cables, and we would just have to rip that whole thing out, and we'd rip it out anyway and start over. And again, this would be done, this was internal to an enclosure, so this would have been a detailed inspection. This is something that's fairly common. And actually, this particular, I won't name who the manufacturer is, but you're not supposed to put a component label on the outside of an EX enclosure. But this is a component certified product. And the reason I know that, it has a U at the end of the certificate. A product that has a U must not be installed by itself. It must be reassessed. You'll notice that there's something missing on the EX marking string. If you're really sharp, you'll notice that there is no temperature code. So what happened here is a manufacturer supplied an empty enclosure. They didn't apply a temperature code to it because they didn't know what was going inside. The client gets the box, goes ahead, puts terminals in there thinking everything's A-okay. And then I go in and I look at it and I say, nope, can't use this because it has a U and there is no temperature code. The reason why it doesn't have a temperature code is the manufacturer doesn't know what's going in the box. So this is a big issue that I see. It happens an awful lot, especially here in the United States, because we're not as familiar with some of the international standards as many people in other parts of the world. But we find this all the time. So I always remind engineers, don't ever buy a product that has a U certificate and just think that you can install this. Let's continue on. This one, and I'm not 100% sure. I think we have some IS and non-IS in this same enclosure. And there's a segregation requirement that we must maintain at least 50 mils separation between IS circuits and non-IS circuits inside panels. So we have definitely violated that. So, and yes, there was a note, is the surface of the red sign too big? It could build up static electricity. And there is a requirement within the standard that does minimize the size of an enclosure's nameplate. Now, that typically will apply primarily to fiberglass boxes, but we do see that in fiberglass boxes because they're typically an anti-static. You could build up a static discharge on a metal nameplate on an enclosure. And that is actually something that we do check as well. This one, we have a broken seal. We could find this. This would hopefully be something that we would see immediately. So we have a flame-proof box, we have a seal off, and then we obviously are missing a seal off. And by the way, this was actually an installation in which an explosion took place, but it wasn't because of this. It was actually an inspection that I did in conjunction with the U.S. Coast Guard for a barge that exploded a couple of years ago. And this was one of the pictures I took, and you could see the quality of the degradation for a marine environment. It was just eating away everything. So here's a fairly common example of what we might find as well. A lot of flame-proof products will have an O-ring that is actually in the box. So what do we do in this situation as an inspector? Well, obviously the O-ring getting crushed in between the flanges, that opens up the flange, which basically defeats the flame path. But could we do something to get this back in service? Now, this is my opinion. This is not something that you would read in any of the standards. But what I told the client in this particular instance is that this was actually an indoor enclosure or located inside, so the IP requirements was not onerous. If you just cut the gasket out and remove that damaged part of the gasket, get yourself another gasket from the manufacturer, replace it, but you can keep that operating in service okay as long as we maintain that flange to flange surface by removing that gasket. So that's a little bit of a judgment call, but generally speaking, we don't want to replace anything that's not from the manufacturer themselves. Now, the fault here, this is an interesting one. There actually is no fault with this one, other than there may be some IS, non-IS segregation. And the only reason, what's important about this is that we need to have a copy of the general arrangement drawing when we're doing an inspection. Because what I found out actually by looking at this, everything looked pretty good. However, there were some additional components that were installed on the inside of this panel after it left the manufacturing facility. So when they added additional components, that potentially could change the temperature code for this entire assembly. So we want to make sure that we're not adding components to an existing enclosure. We can replace components if it's damaged, that's okay. But to add additional components is not okay because that will change its temperature characteristics. So there's our EX register. It will look something like this, where it has a description, a part number, the markings, and there's our X condition. And if you notice on the first one, it's a little Vega unit, and it says the flame path not to be repaired unless by factory. Well, that's pretty much a given. We inspectors and you as the user don't want to repair flame paths. That's not something that we really want to do. Okay. So some of the tools available as an inspector, what kind of tools do we have available? Well, there's everything from EX tablets. There are asset inspection softwares. We have RFID tags. So there's a lot of tools available to help streamline this inspection process. We provide those types of tools to clients, and especially if they've got a tremendous amount of assets. And it's fairly common for a lot of facilities that they've standardized on some sort of electronic way of doing these inspections. And these inspection check sheets that you'll see are based upon the -17 standard, and they can usually be customized specifically for a customer. But again, we don't want to take anything into a hazardous location unless they're certified or we have a gas-free permit. So another poll question. Which of these do not have an inspection schedule chart? And you guys are paying attention. That's a good thing. So you guys are correct. Most everybody is saying the right thing. So C is the one that does not have an inspection schedule chart. We do have it for flameproof, we do have it for increased safety, and we do have them for pressurized, but not encapsulation. There was another question on intervals for periodic inspections, and we'll talk about that here in just a minute.
Bob, we do have some questions also if you want to have a look.
Yeah, let's see. Good example for intrinsic flame proof. Are there any common examples for other certifications such as oil immersion, encapsulation, powder filling, and pressurization? I do have pictures. I just don't have them here in the presentation, but I'd be happy if you would like to drop me an email at the end of the presentation, or anybody drop me an email. If there's something in particular you would like, just let me know. I think there was another question. Yeah, the intervals. I will tell you, all EX equipment by the IEC standard, the -17 standard, is every piece of equipment must be inspected at least once every 3 years. Now, there's some exceptions to that. So for example, if it's tools that we're taking into hazardous locations, the requirement is every year. But in reality, we should be doing it every time that before we take it into a hazardous location. The other requirement is for enclosures in which we're opening up and closing the doors fairly frequently. So we might have a battery enclosure or something like that. Those have to undergo a detailed inspection every 6 months. That's what the standard says. Now, as a side note, in Australia, their intervals are actually 4 years. It's not 3 years, they're actually 4 years. So some countries will be a little bit different. Some regulators will insist on differences. But if we follow the standard, every piece of equipment must be inspected at least once every 3 years. The important thing to note, it doesn't mean that it has to be a detailed inspection. It could be a visual or close inspection. So if we walk around and something's been installed for 3 years and it's in a nice clean environment, and we look at that piece of equipment and we have the register, we have the information from a prior inspection, and we look at it, what we're looking at is what is the environmental condition of this? And is it the same product, right? If it's the same product and it's the same and the environmental condition is good, well, we don't need to open up everything and start re-looking at it. We'll just leave it alone and say, we've done our inspection, we'll come back to it in 3 years. If, on the other hand, we have equipment that is installed in a very corrosive environment, we might move our inspection schedule up further, maybe every year, or maybe every 2 years, and we may require a detailed inspection. That's typically the frequency, duration, type of inspection is really left up to the regulator or the client, the regulator or the client. So a couple things before we get into the Q&A. If you think it's a fault, write it down. Become competent. Get yourself competent. There's EX competency courses that you can learn and train to become a competent EX inspector. This is the big thing. Realize you don't know everything. I tell myself all the time, I'm always finding new things. Because again, you'll face something that you've not seen before. That's okay. Read, research, do a lot of that stuff. The standards are changing all the time. So the standards change, you have to stay on top of it. Don't let any outside influences affect your judgment. These are safety critical functions. Lives do depend on your work. Regardless if you're an official inspector, right? It doesn't mean that you can't be inspecting in your normal day-to-day work. If you're around a lot of EX equipment, take a look at something, just look at it. Hey, it doesn't look safe, report it to your supervisor. And again, the standards do change, so we need to make sure that we stay on top of it. And again, safety begins with you. So don't go away, because we do have some other questions and other things that we're going to be doing. And let me close this down. And I'm going to stop sharing for just a second. And I will bring up the other presentation if I can find it here. Bear with me. I need to exit this. Andrea, you there? Hello? Hopefully I didn't get cut off. So I am going to share my screen as soon as it comes up. I know we're running a little bit close to the time of ending, so we only have, I think, maybe about 6 or 7 questions. So if you can hang around for another, hopefully, a few minutes, I'll bring this up and then we can look at this and go through this. And that's not the file I want to look at. Have you got the Q&A, Andrea? I'm trying to bring mine up. You're muted.
Yeah, I got. Sorry, I was disconnected.
Oh,
Let
no
me
problem.
check.
I'm bringing mine up as well. So I tell you what, I'll do my.
Yeah, I'm here.
It's always fun doing these presentations from 2 different locations using doing all this good stuff. Okay,
Yeah.
I think I can share it now.
Can you? Otherwise, have it here.
I think I've got it hopefully shared. Are you seeing my screen?
Not yet? Yes, right. Yeah, yeah.
Yep. Okay. So just a couple different questions. What is the expectation from the regulator authority on EX inspections? So most of these regulators are using the -17. Some organizations have been doing this for years and years and years. The HSC in the UK has been very active in this. We're now starting to see other organizations, especially in the maritime industry, because now we're introducing liquefied natural gas, ammonia, and hydrogen for fuel. So now some of these other governing bodies are really getting involved, right? So, however, what's really driving this isn't so much the regulators per se, it's in many cases the owner operators. So, what they're asking, the regulators, they're asking that this is all done by competent people and then there's document available to be reviewed. That's what the regulators are typically doing. For example, we train a lot of US Coast Guard inspectors. They're not going to go and start inspecting all pieces of equipment, but they will ask to see registers. They want to see that you have all this documentation. They may ask to see whether or not the people that are doing these inspections, what are their qualifications. Those are the kinds of things, because they don't have time to go and inspect, 500 or 10,000 items, but they will expect certain things. So that's the kind of stuff that the regulators will typically ask for. So what are some of the key differences between the -14 standard that was the new one that was published in 2024 and the new one? And instead of going through that, because it's a huge amount of changes, what I would recommend is, as I mentioned, we teach Compex. The Compex organization, if you do a search, you will find that they have put together a really, really, really good guide, and it's free of charge. You can download it. You just do a search for Compex certification and do this and download this. It'll give you a lot of good information as far as what some of the changes are. This is the new flow chart, and we don't really have time to go through it, but this is the new flow chart that is now for the use of barrier glands or non-barrier glands. And I know this topic, we could talk for hours on this one, so I'll just make note that it has changed. The 3-meter rule has gone away that you guys may be familiar with, and it's gone to this new flow chart. So be aware of that. So inspection on EXD barrier glands, many of them you can't open because they're potted with too much compound, and many are filled up with too large cables. Is there an easier way to confirm? Well, unfortunately, not really. But what we do want to see with barrier glands, so some manufacturers have come out with a clear, resin chamber, or in the case of other manufacturers, they may have a portion of their resin chamber clear, but not the entire thing. It is very difficult to actually inspect to see whether or not a barrier gland is properly installed. But what I look for a barrier gland, and what we teach, is that I don't want to see if it's a clear one like what we see on the left-hand side. What I don't want to see is any cable striations. I don't want to see any air gaps, any bubbles. That's what I want to look for. What is the role of an EX inspector at the design phase of a project, if any? And it's a good question. Generally, an inspector is not going to be involved at the early stages. I think it's really more important that the designer, if you will, is really understanding of what the inspectors are going to be looking for and make sure that whatever instructions are in place for whoever is doing the construction, either internally or an external contractor, that they follow those instructions very, very clearly. Because if that's done, then as an inspector comes in, I'm going to follow what the designer has put forth, right? So it's always a good point for, I think, as many people to understand what the inspectors are looking for, but whether or not they need to be involved at the early stages, I would say fantastic. I get called sometimes from people that are putting work together and everything else, and they may send me the key things and they want my interpretation. I'm happy to do that. I do that all the time. So, and I'll tell them, hey, well, these are the things, if I was going to be doing this inspection, this is what they're asking. And so you need to be doing this, this, and this. And if there's any issues, we'll obviously bring it up with the client to have that discussion. Cold flow, cable glands. So this is an example of cold flow. So you see this reference in the standard. Sometimes this comes up. So cable glands are designed to not allow cold flow taking place. And cold flow is two pieces of elastomer material after it's being compressed, flowing away from each other. So as you imagine, if we're using cable glands, we could have cold flow on the outer jacket. That could affect its IP rating. But if we also have cold flow on an inner bedding and we're using an inner bedding as a flame-proof seal and we have cold flow, well, at that point, then we've lost our flame-proof seal. So cold flow is a big issue. We look at glands. This comes from either over-tightening of the gland. It can also come from certain cable types or more susceptible to this. So just be aware of it. These are some examples of some extreme examples of cold flow with certain seals. So you'll see on the far right-hand side, some seals and cable glands, you'll actually see that they'll have this cut groove, and then when they compress it down, if they keep compressing, it'll actually cause a dramatic failure of the cable. That's a pretty dramatic example where it's literally causing all of the material, the elastomeric material, to move and exposing, in this case, some shields. How do we identify fake EX equipment? So this is a great point, and it's coming up more and more. We see this all the time. A couple things. On the right-hand side, that particular cable gland was marketed as a Hawk cable gland. Now, I don't want to bring up brands and all that other good stuff, but we use Hawk a lot. I sell Hawk. That is not a Hawk gland, and I could tell from the back nut because of the design. So that was definitely a gland that was not from them. But what you see on the bottom right-hand side, you'll actually see some manufacturers are putting little hologramic images, and you can actually go onto that manufacturer's website and actually put in that little barcode, and it'll tell you, yes, this is an authorized piece of equipment. It was manufactured by us, blah, blah, blah. The other thing that you can do is go to the IECEx website. You can download certificates, and you can certainly at least know that it's certified if it's if the people that are building the fake equipment copy that as well. Well, then we may want to go back and start looking at serial numbers and actually reach out to the manufacturer. And I've had that happen before where we had some equipment that I thought was real, but it was actually counterfeit product. And the way we validated that was by contacting the manufacturer. The serial numbers didn't work up. So it's getting more and more difficult because a lot of these counterfeit manufacturers are getting really good at copying other manufacturers' products. Using an EX safety barrier for gas detectors. Yes, we can certainly use a gas or a safety barrier for gas detectors. We can put them in a zone 1 area by placing them inside of an EXD flameproof or EXP pressurized enclosure. There are some specific details within the 29-2 for the selection and installation of gas detectors that are pulled out of, or a little bit slightly different from the requirements of Dash 14. I shouldn't say different. The 14 gives you a lot of general information. The 29-2 gives you a little bit more detailed information as to the selection and installation of gas detectors. And again, some of these gas detectors, you'll find that they're rated both EXD or EXI. So in many cases, we could, again, protect it with the use of a barrier. A barrier can also be placed in a zone 2 area, because most of these barriers now, certainly GMIs are rated for installation in a zone 2 environment. But if we need to put them closer to the device, we certainly could do that by placing them inside other protection concepts. What about repairing and replacing EX certified components without voiding? So there is a standard for that for repairs. The Dash 19 is a standard that has been published. And what you see over on the right-hand side are examples of labels that you would actually put on this piece of equipment after it's been repaired by an authorized repair facility. So that's different. That's where maybe we're having to have this thing remachined. Maybe we've got a big monstrous motor and we don't want to spend $100,000 or wait 52 weeks. We can send it to a motor rewind center, and if they're already an IEC-EX, if you will, certification center under that standard, then they can do the repairs and the modifications and then send it back to you. And it'll have one of two labels. It'll have a label either saying it's repaired to the standard in which it was built originally to, or it'll have a different one that'll say this has been repaired to the latest standard. So if it's an older piece of equipment, you would have the one label and the other. And I always forget which one is which, so don't ask me which one is which. Here's the other thing though. If I have, say, for example, a flame-proof enclosure or pressurized enclosure or whatever, and maybe I've got a bad ABB starter and I want to replace it with another starter, I would replace it with the same starter, the same brand. The moment that we start putting different manufacturers, we should make a risk assessment to determine that the change of the component will not jeopardize the safety in any way. What is the safety factor that we're concerned by adding additional components? Generally, it's the heat temperature rise, because we could violate the temperature code by adding additional components or even changing those components. Or in the case of flame-proof, by adding additional components, we could jeopardize and create what is called pressure piling, which could cause a failure of the enclosure to actually do its job. So we really want to check with the manufacturer before we do anything like that. But generally speaking, replacing like for like is not an issue. What are some of the most common things that we find? And this is really from the design engineer side. So again, use certified enclosure. We don't consider the X conditions. Maybe again, like on that right-hand side, multiple protection concepts, but not clarifying which one is the appropriate. Maybe not enough drilled and tapped entries into EXD enclosures to anticipate what additions may be needed once in the field, because we're not allowed to drill and tap flame-proof boxes in the field. So it's always best, if I'm a designer, if I know I need 10 entries, I'm going to buy a box, have the manufacturer put 15, and then I'll plug them up with certified plugs. Not creating a descriptive system document for IS systems, which is a requirement. And there's that picture of a shroud that, again, it's holding in the dirt, moisture. It causes premature failure of cable glands, and it actually does more harm than good. I'd like to know who gets to decide whether a set of enclosures are to be certified as EX. As control system suppliers, what value addition we can do. You need to understand what the project requirements, right? Then you can determine which protection concept works best for you, flame-proof, intrinsic safety, whatever it is. As a control system panel builder, right, you have various options. And the more you know, you can provide a more cost-effective, maybe easier way of a user-friendly type solution, which I think does provide value. And certainly you can, depending on the supply chain and everything else and the concepts that you're using, if you have those options available, that maybe you have one design around EXD or another one around EXP or another one around EXI, that provides the most flexibility. And certainly if in a pinch, maybe you can produce something in 10 weeks or 12 weeks if we use this protection concept, as opposed to 20 weeks using a different concept. And then, of course, understanding what the certification bodies are going to want to see and defining that will help streamline that process. Again, how often does equipment need to be inspected? We talked about this within a 3-year period. Do I need to have a specific inspection for EXI connected field instruments for meeting the minimum of preventing, controlling, mitigation of major accident hazard? Yeah, we are required to inspect IS systems as well, but we do have to do some different things under IS. We have to make sure that there is a descriptive system document, and that gives us all the details, including the entity parameters of the output of the input devices and the cable lengths details. One thing that people do forget when we're using intrinsic safety, there is a limiting factor with regards to the length of cable that we can use, because cable will store power, inductance, and capacitance. And if we exceed the minimum ignition energy of the particular gas vapor in the atmosphere, then we could create a dangerous situation. So our DSD is basically our check, if you will. That's telling us, okay, our cable length cannot be any longer than 200 meters for this application. So that's why the DSDs are so important. And certainly how defeating barriers, if you see the picture on the bottom left or bottom right, excuse me, it's very easy to defeat barriers. That's a real world situation where the fuses probably blew on those Zener barriers. And because now we're not getting a signal, somebody in the field said, well, these are not doing me any good, I'll just bypass them. So now we have basically turned those sensors or those devices, they have no protection whatsoever. So that's a very dangerous situation. We do not want to do that. I think a former designer or a former installer. It is a great question. My colleague Wayne and I do inspections. He came from the installer background. I came from manufacturing background, and we both look at things slightly different, but we learn from each other. So I don't necessarily know if there's one that's better than the other, but I've learned from Wayne. Wayne has learned from me. It's always good to talk to other inspectors, talk to colleagues in the EX world, learn as much as you can. And again, if you do think it's a safety issue, write it down. Will the 14 and 17 be merged? No, they will stay separate. And actually in the United States, we do not recognize the -14 standard because we have the NFPA 70, which is an installation standard. However, we have adopted the inspection standard. So we do have that. And then the one thing that has changed, the latest edition of 14 has now included the requirements for initial detailed inspection using the inspection tables from 14 standard. So I flew through that. I know I ran a little bit long, and I hope many of you stayed, and it looks like a lot of you did. But I know there was a lot of information. We tried to cover as much as we possibly can, but obviously, please reach out to myself or Andrea if we can answer any further questions, or if we didn't get a chance to answer your question, because definitely want to make sure we do this. There was a question that did come up, if we need to add components to an EXD enclosure, how do we recertify the whole enclosure? What are the options? So generally, when we do add components, we have to be concerned on EXD. The temperature is number one, as well as pressure piling potentially. So there is a way to get under ATEX and IECEx, there is a way to get a what is called unit verification. That's like a one-off, if you will. So the best approach is reach out to the IECEx or ATEX notified body, the IECEx certifying body, and present this question. They typically will come in and they can actually do a recertification of that existing panel. However, it's going to cost a fair amount of money. So try not to do that, but that is an option. You do have that option. The other question.
Great, thank you. Yeah, you have another question, Bob?
Yeah, that periodic inspection needs to be done in 3 years. Is it done by a third party or could be done by company's own certified inspector? That's a great question. It's really up to the company or the regulators. And I know of some companies that insist on having a third party come in, so we'll come in and do it. On the other hand, we train people to do inspections and they can do it themselves. And maybe have a third party to just kind of maybe do a spot check of their work. So, ideally, I think it would be more internally to have more of your people or more of an organization's people be certified to do these inspections. And then, it's certainly going to cost less because you're doing it internally. These are employees. They can do that. But some companies will say, well, look, we want to have an extra set of eyes, a different set of eyes, somebody that's maybe not biased or anything like that to come in and actually take a look at it. So there's no necessarily one right answer, but I would say the trend is more outside inspectors than internal.
It's possible to see the slides. I guess we can send the slides after the webinar. You will
Yes.
get it. Sure.
Yeah.
Yeah.
And I am alive. I am live. There we go. Well, hopefully we've answered your questions that you came in here with. But obviously, if there's something else that we didn't cover, please let us know. And we have.
It was very fruitful, I guess, this presentation. A lot of information, a lot of things. I think people appreciate it. I've seen also from the feedback. Thank you very much, Rob. Thank you.
Yeah. No, thank you, everybody. And I know I kept you a little bit longer, but I really, really appreciate you guys paying attention and participating. And we do these webinars on various topics. I would very much encourage you to go to the GM International's website, go to the existing webinars. And if you get a chance, we've got, I don't know, we've done probably about 8 different topics. Everything from reading labels to understanding some of the EX protection concepts to all different kinds of topics there. So if you're home enjoying an adult beverage or something like that and want to just waste a little bit of time on YouTube, go to the GMI website. You can actually have a link to all of those videos so you can check them out. And hopefully there'll be some good information that you might increase your knowledge in the EX field.
Not only, because we have also a lot of webinars for SIL, functional safety, a lot of webinars also on the application, products, and so on. So you can have a look at that. And more, I think, more topic will come in the next future. So just to remind you to check and maybe connect over LinkedIn with GMI, so we get all news. And if you go on the training, the specific page of GMI training, you can see our next webinar. And of course, very important, as Bob said, the YouTube channel where all webinars are recorded and stored. Thank you again, Bob.
Well, thank you, Andrea, and thank you everybody for participating, and have a wonderful evening or afternoon wherever you may be located.
Yeah, exactly. You too. Thank you very much and see you soon. Bye-bye.
Okay, bye-bye.
Bye-bye.